Hello, hello. It's time for the third section of this week's lesson plans, which means using oxidation numbers and using your ability to identify the oxidizing agent, the reducing agent. You now are going to be able to balance those redox equations with oxidation numbers. So a different method. Before, we balanced redox reactions with half reactions. Now you're balancing redox reactions with oxidation numbers. Another way to accomplish the same goal. Now, ultimately, guys, by using those oxidation numbers to figure out which particular chemicals lost electrons and were oxidized, or which particular chemicals gained electrons and reduced, we can use those numbers to predict how electrons have been gained and lost, and therefore balance in turn. All right, here's your steps. These are going to be really helpful for you to go step by step through. Try to memorize them. It'll make your life easier. Step 1 and 2 are the exact same thing that we've done already. You've done those in the previous 2 lessons, so no big deal. The next step, though, is a little bit different. We need to figure out the number of electrons that are gained by the oxidizing agent or vice versa, lost by the reducing agent. Now, keep in mind, when I say the number of electrons gained, I'm talking very specifically here about the total number of electrons. We already looked at how many electrons are gained or lost by a single atom, but the total involves all the atoms that are gaining and losing that particular number of electrons. So be careful. Now, in terms of the OA and the RA, when we figure out the balancing of the electrons, we're going to talk about coefficients for those. So balance those electrons and then apply those simple number coefficients. Now here's, you got to be careful, only to start the OA and the RA. We leave all the other chemicals alone until step 5. Step 5, and it's important that this is last, this is when the other atoms and the other ions in the equation are done by both inspection and charged and are balanced. Okay, remember that OA and the RA, when we do that in step 4, these are both going to be reactants, which means we're completely ignoring the product balancing until we get to step 5. This will make more sense as we actually keep going. Once you get to balancing the other ones, guys, kind of a good step-by-step is start by balancing all the other elements or all the other atoms except your oxygen and your hydrogen. Leave those until later. So step 2, move on to the water next. This is similar to how we were balancing in previous types of balance questions, right? So balance water, or sorry, balance oxygen with water, I should say. Right? Balance the oxygen. Usually water helps you do that. And last but not least is balance those hydrogens. Okay, check it out. Let's try one. See how it works. So first things first, and sorry, when I redo this, it ends up squishing things a little bit. So I'm going to actually move and rewrite this one over here. CH3 COOH, aqueous, which means that you can ignore this one over here. And of course, this is supposed to be that arrow, right? Going from reactants to products. Okay, step by step. Step 1, assign oxidation numbers. And again, we've seen this reaction. This is the same reaction that we did in yesterday's lesson where you were simply identifying an OA and the RA. So I'm going to go through the oxidation numbers here and just write them out really quickly because you've done this type 1 before, right? So +6, -2, +1 on the H+. This carbon ends up having a -2 charge. Hydrogen's always that -1 unless it's a metal hydride, which this isn't. Oxygen -2, +1 for hydrogen. +3 for that chromium, +1 for hydrogen, -2 oxygen. These carbons have a net charge of 0, +1, -2, -2, and +1. And away we go. Okay, let's keep going with this. So next step, again, is the same thing you've already done before. Identify the oxidizing agent, identify the reducing agent. This is similar to what we did before. We're going from our chromium with a 6 plus to a chromium with a 3 plus. Well, the only way that's going to happen is if we have a gain of electrons. How many? Now, this is where things get interesting. It's going to gain 3 electrons. Now, pay attention, per a chromium atom. Well, there's 2 of them there, so 3 electrons per a chromium atom. But if we've got 2 chromium atoms, then I have to times that by 2, because 2 in total are going to be gaining. 3 times 2, and that's 2 chromium atoms, is going to equal a total of 6 electrons gained, right? Keep in mind, of course, this cancels out, and it all works out. Electrons. Okay, look at what's happening on the other side to where we're dealing with that carbon. Carbon is going from -2 up down to 0. So for that to happen, it's going to be losing electrons. How many? It's going to be losing 2 electrons. Again, 2 electrons per a carbon atom. Well, we need to multiply that by the 2 carbons that are reacting. So times 2 atoms, this is actually going to be a total of 4 electrons. Well, if we've got 4 electrons being lost and vice versa, we've got a total of 6 electrons that are being gained, then that doesn't balance out. This is an issue, guys. It's really, really important that these are going to balance. 4 electrons does not cancel out 6, similar to what we've done in the past. So how do you make that balance? You got to do some multiplying. Take that 6, and we're going to times it by 2, and we'll get to 12 electrons gained. Perfect. Vice versa, take that 4, we're going to times it by 3, now we're at 12 electrons lost. Well, this is what we need. If 12 electrons have been gained and 12 electrons have been lost, then we're golden. We've got a nice balanced reaction based on electrons. Now, electrons balanced is great, but we still need to balance out all the other atoms. So here's where things get a little bit interesting. First of all, we're going to rewrite this and make sure that you leave some room with everything. So we start with our dichromate. Cr2O7, 2 negative, aqueous. Okay, now that dichromate, if you think back, I had to multiply it by all the way over here. Let's say I'll highlight it by 2, right? We had to multiply it by 2 in order to make those electrons balance. So that means I have to do the same thing with my oxidizing agent then, right? So if it gained electrons, it underwent a reduction. It's an oxidizing agent, times it by 2. Okay, keep going. Plus. Now, we're not going to do anything else to the H plus yet. We're going to have to do it later, but for now, just leave it alone. Plus. Now, we're on that C2H5OH aqueous. Similar type thing. I had to take that one before, and I had to multiply it by 3. Multiplying it by 3 to get it to 12 electrons lost, because it was an oxidation reaction. If it lost those electrons, it's oxidation, which means if I times it by 3 as a reducing agent, I have to times that entire reducing agent by 3. Okay, now we're getting somewhere. Keep on writing things out as they are at this point. So leave room for you to actually put the balancing. We've got Cr3 plus aqueous plus H2O liquid plus CH3COOH aqueous. Okay, Now we're at that point in the balancing where I said, now you need to balance everything that's not oxygen and everything that's not hydrogen. So let's start with the chromiums at the beginning. Cr2 times 2, we've got 4 chromiums reacting, which means I'm going to have to put a 4 here to have a total of 4 being produced. Now go to the carbons that are there. We've got a total of 3 times 2, 6 carbons reacting. So same thing, I need 6 being produced. Be careful, there's 2 of them here. So I just need to put a 3 in front. 3 times 2 will give me my 6. Now we're on to the oxygens. Count carefully. If you start looking at what's what, one side definitely has more oxygens than the other. And it's the left side. So we're going to be able to multiply the waters on this side to get enough oxygens. Okay, check out dichromate. 2 times 7, there's 14 oxygens in total here. Vice versa over here, 3 times 1, there's 3 oxygens in total over here. Okay, we've got 17 oxygens in total reacting. Look at what's produced. I already have 2 times 3 oxygens here, so there's already 6 oxygens. Now, remember what we said, we had 17 oxygens going in. At this point, I only have 6 oxygens going out. I need another 11 to be added to that 6 to get to 17. Well, that's where this comes in. Times water by 11, I now have an extra 11 oxygens. Okay, let's move on to our hydrogens. Hydrogens get interesting. Between this water here and my CH3COOH, I have a total of 34 hydrogens, right? Just in water, there's 22. Just in the CH3COOH, I've got a total of 12. So 34 hydrogens total. Now go over to this side, and I've got in this one, C2H5OH, a total of 18 hydrogens. Okay, that's nowhere close to 34. How many more do I need to add to 18 to get to 34? Well, 16. So that's where this goes from. Now it works. 16 plus 18 is 34 going in, 34 coming out. We're balanced, folks. This is officially ready to go. Check it out. 2 chromiums, 16 H plus, 3 of my ethanol, C2H5OH, 4 chromium 3 plus coming out, 11 waters, and 3 of the ethanoic acid. Done and done. It's a process. You might want to go back and listen to it again, but if you're ready, let's try the next one. Now, take note, this is being done under acidic conditions. That's why in this reaction already H plus has been put in there, and so has water. Anytime an acid is present, water and H plus are going to be factors that you can use, which is good, because how else would we balance that oxygen and hydrogen? We need those. Okay, step by step. Step 1, begin with assigning your oxidation numbers. This one gets interesting. Assign the easy ones first. +1 on that hydrogen, -2 on oxygen, +1, -2. Manganese 3 plus is easy. It's a +3, +1, -2. Okay, let's again go to what's easy first. Look at this carbon. -2 times 2 is -4. I balance that out with a +4. Jumping over to the manganese. This one's pretty easy too. 3 times -2 is -6. I still need a charge of -1, so I'm going to add a +5. +5 plus -6 is -1. This carbon gets tough. Okay, I'll show you a step-by-step for it. We end up with a funny fraction. We've got 3 carbons, and those 3 carbons are being added to 8 times +1, and that's going to get us 0. So we've got 3 carbons plus 8 to get us to 0. That means when we subtract the 8 and divide by 3, carbon is equal to -8/3. Okay, think about this a little bit. That gets interesting when we figure out how many electrons are being gained and lost. Okay, I'm going to erase this thing here. All right, let's keep going. we need to look at how the oxidation numbers are changing. There's no doubt that carbon is changing to go from -8/3 to +4. And again, this is where I said, and this gets a little tough. Now the number's going up, which means guaranteed you're losing electrons. So think about it numerically. We're going from -8/3, and we're going to subtract an electron, minus a negative, which is the same thing as adding, right? So minus a negative is plus. So -8/3 plus x is going to give us the final oxidation number of +4. Honestly, I would on here use your calculator, right? I mean, you can play around with the fractions and stuff if you want, but you can also just go on your calculator, okay? Figure out what's what. How do you get rid of -8/3? You add 8/3. What you do to one side, you do the other side, right? These will cancel out. X is equal to, on your calculators, what I would do is go 4 plus and then put it in a bracket. 8 divided by 3, enter. You're going to get 6.6 repeating, okay? Take that number, don't write it as 6.6 repeating. Instead, go math, choose number 1, which is fraction, and you're going to get 20/3, okay? That means that 20/3 that we can know, and again, think, the oxidation number went from a negative to a positive. So loss, right? How many? Well, here's where it's weird. 20/3 electrons. Don't let that fraction bother you. It'll go to a whole number eventually, okay? 20/3 electrons, and remember, this is per a carbon atom. No, I don't want to zoom. There we go. Okay, there we go. How many carbon atoms actually were reacting? 3 of them. So we're going to take that and times it by 3. Again, if you've still got the fraction in your calculator, you can just leave it. 20/3 times by 3, dun, da, da, da. We have 20 electrons total that are going to be lost. Okay, here we go. Let's look at the next one. Check out manganese. Manganese goes from a +5 to a +3. Only way that that's going to happen is if electrons are gained. And indeed, that's what occurs here, okay? To go from +5 to +3 is going to involve a gain. All right, hopefully there's not too big of a glitch in the video. I'll try to splice them together. Otherwise, you're going to have these two separately. So we were at that point, if you remember back, that I was saying that the manganese is going to gain a total of 2 electrons to go from 5 plus to +3. And again, that's per an atom, but if you notice, that manganese is only 1 atom going in as a reactant and 1 going out as a product. So that 2 electrons works good as it is. Okay, take a look at what's happening here. Our gaining of electrons is reduction, and you gain 2 electrons. Our losing of electrons is oxidation, and it gained 20, and that's not good enough. We need those to balance out. We're going to do that by taking the gain of 2, timesing it by a total of 10. Now we have those 20 electrons gained, which matches the 20 electrons lost. Okay. From here, we can start to actually write our full balanced reaction. Okay, think about what happened. That C3H8, which is propane gas, I didn't have to multiply it by anything because it already had those 20 electrons, and I just had to multiply the reduction reaction to get it to 20. So there's 1 of them. That one's good. Plus, all right, my MnO3 negative aqueous. And this one I did have to multiply, and I multiplied it by 10. All right, that 10 came from right here, okay? All right, so if we take that, continue on, plus, don't balance the H plus yet, produces CO2, gas. Well, this one I can start to balance Because over on this side, if you remember back, I have 3 carbons. So I'm like, okay, I'm going to need 3 carbons over here. Okay, so far so good. Plus, now I've got the manganese, 3 plus aqueous. Similar type thing. If over here we've got a total of 10 manganese, then I'm going to have to take that and multiply this one by 10 to balance out my non-oxygen and my non-hydrogen atoms. And last but not least is put the water on there. Oh, and I see I've got water aqueous. This should be water liquid. Okay, liquid water. Okay, let's keep going. All of my non-oxygen, non-hydrogen atoms are now balanced. So now we're on to oxygen. Have a look. Consider what we've got here. When you look on this left-hand side, I've got a total of a whole lot of oxygen, right? Over here, we've got 30 of them. 30 oxygens. Over here, we've only got 6 in that carbon dioxide, 3 times 2. So that means on that water, I'm going to have to put another 24. 24 plus 6 will get me to 30. Oxygens are balanced. Okay, start going into the hydrogens. Hydrogen is only in water over here, but I got a lot of them. 48 hydrogens in total. Vice versa, if I go to this side, I've only got 8 hydrogens right here, which tells me I need another 40 to get up to 48. 8 hydrogens plus 40 hydrogens will get me to 48. Where does that 40 go? Right in front of the H+. And there you have it. We're balanced. We have a single 1 propane, 10 MnO3 negative, 40 H pluses produces, 3 carbon dioxides, 10 manganese 3 plus ions, and 24 waters. And that's the end of today's lesson. Have a good day, guys.